In 1900, Max Planck presented his landmark paper on black body radiation. In that work, he introduced a revolutionary idea, the idea of a quantum of energy. At that time, most prominent physicists did not even believe in the existence of atoms, let alone subatomic particles. Matter was generally thought of as infinitely divisible and continuous substance. The assumption was that if we divide matter into smaller and smaller pieces, its property would simply become smaller and smaller in magnitude. So, the initial idea that matter might not be infinitely divisible was itself a major revolution in the physics community. But today, the situation is completely different. Modern technology, including communications, electronics, space exploration, and biotechnology, depends heavily on quantum theory. In fact, quantum theory is the most successful and valuable theory science has ever developed. But despite all of its success, the fundamentals of quantum theory remain mysterious. And in many ways, they are as mysterious today as they were when the theory was originally formulated. The early founders of quantum theory, that's Planck, Einstein, Bohr, Heisenberg, Schrödinger, debated the meaning of quantum principles and their exact significance. For them, it was important not only to use the theory but also to understand it. They wanted to understand its meaning and its wider philosophical implications. But during the last 60 years, the approach to quantum theory changed significantly. Physicists such as Richard Feynman and Freeman Dyson helped establish a culture in which the ability to calculate and predict became central. From this point of view, quantum theory does not necessarily need an interpretation. It's like if the theory can make correct predictions, then perhaps that is enough. So, in this view, we don't need to know what quantum theory ultimately means. We simply need to use its mathematical formalism to calculate measurable outcomes. And because of this attitude, writing about the philosophy or interpretation of quantum theory is not always considered the most respectable professional choice within physics. It remains more accepted as a subject for philosophers. But what philosophers say about the meaning of quantum theory does not necessarily make headlines in the world of physics. Physicists widely believe that speculating about the meaning of the rules by which quantum theory operates is unnecessary. After all, like imagine that we are playing football. So we don't normally spend our time asking why a football field has a particular size or why a tennis ball must have a particular diameter. We simply accept the rules of the game. From this perspective, the rules of quantum theory are no more meaningful than the rules of any other game. The quantum formalism is a mathematical theory that makes predictions, and the methods we use to calculate measurable outcomes do not necessarily need to have some deeper meaning behind them. Underlying this view is the belief that an interpretation does not add anything essential to the theory itself. There can be many different ways of looking at a theory while remaining consistent with the same mathematics. These different views can be understood as different models of the theory. Like, consider a simple example. Suppose we have the equation a plus b equals to c. Now, depending on how we look at it, this equation can have no particular meaning or it can have different meanings. For example, A could represent 5 apples and B could represent 5 oranges. Then C could represent 10 fruits. But the same equation could represent something completely different. A could represent the number of people below the age of 50. B could represent the number of people above the age of 50. and C could represent the total number of people. There could be countless other interpretations. The mathematical relationship remains exactly the same. What changes is what we understand A, B, and C to represent. So, this act of giving meaning to a mathematical formula creates one particular way of understanding it. This is sometimes called a model of the theory. But according to the common view, we don't necessarily need such models. Physicists similarly argue that different interpretations of quantum theory do not change the theory itself. Each interpretation is simply one possible way of understanding the same mathematical formalism, and no single interpretation necessarily eliminates all the others. Critics of interpretations therefore argue that the mathematical theory is compatible with the multiple interpretations. An interpretation is simply a particular way in which we choose to think about the theory. It does not change the theory itself.